Alright, in this video I'm going to be solving systems of equations using Gaussian elimination. Sounds kind of complicated, but it's really just row operations. And they're not really super complicated, they're just long and they involve lots of tedious calculations. You gotta be really careful on these because if you make one mistake, it'll mess the whole thing up. So let's go ahead and get started. So here's a system of equations in two variables, and so the first thing I want to do is write this in matrix form, write it using what we call an augmented matrix, and we're gonna actually I'm gonna go ahead and write the form that we want to get. It's where we have ones on the main diagonal, 0 below that first one, and then numbers everywhere else. So we're going to take the matrix that goes with this system. Let's go ahead and write that. This is row echelon form, by the way. So there's the corresponding augmented matrix, and we want to get it into this form here. So the first thing we do is we start in the upper left-hand corner, and we want to get a 1 there. Now there's three types of row operations we can do. We know that we can interchange rows. We also can multiply a row by some non-zero number or constant. And then the other thing we can do is multiply one row by something and add it to another row to replace that other row. So let's go ahead and do this. In this case, I look at the first row and I notice that all of those numbers are even. In fact, if we divide everything by 2, we'll get 1 in that upper left-hand position, which is what we want. So when we're doing matrix operations like this, we use multiplication. So instead of dividing by 2, we'll actually multiply by the reciprocal, which is a half. So we're going to do 1/2 times row 1, and that'll become the new row 1. So let's go ahead and do that. Notice I've written in row 2 because that's not going to change. So 1/2 of 2 is 1, half of -4 is -2, and half of 10 is 5. Alright, so now once you get a 1, you normally are going to need to use that 1 to get a 0 right below it. So we need to get rid of that -2 right here. So we're going to have to multiply the first row by 2, add the two rows together, and we'll get the 0 that we need in that first place there. So let's go ahead and do this. So we're doing 2 times row 1, and we're going to add that to row 2, and that becomes the new row 2. So again, I'm going to go ahead and write the matrix in with the first row there. I don't want to mess with the first row. And let's go ahead and multiply each of the first row elements, or each of those numbers, by 2. So 2 times 1 is 2, 2 times -2 is -4, and 2 times 5 is 10. And now we're going to add these numbers to the numbers in the third row. I'm sorry, the second row. So 2 and -2 is 0, -4 and 1 is -3, and 10 and -1 gives you 9. Alright, so now we have the 0 below the 1, so now we're going to move down the diagonal this way. And we need to get a 1 where that -3 is. Well, -3 and 9 are both divisible by 3, so here we can just multiply by the reciprocal of -3, which will be -1/3, and that'll get the 1 that we need. Really, you could just think of this as division by -3. So let's go ahead and do that. It's -1/3 times row 3. That's going to become our new row 3. Again, I'm really just dividing by -3. So notice I've rewritten the first row, and of course 0 divided by -3 is 0. -3 divided by -3 is 1, and 9 divided by -3 gives us the -3 there. All right, so finally we have this in row echelon form. So we could actually go further and get a 0 above this one right here. But we're going to leave it in this form, and we're going to actually change it back into equation form. So notice we would have 1x minus 2y equals 5, and y is equal to negative 3. Since y is negative 3, we can plug that into the other equation there. We'll get x minus 2 times negative 3 is equal to 5, or x plus 6 equals 5. Let's subtract 6 on both sides, and so we're going to get negative 1. And so our final solution is negative 1, negative 3. Now I know we've learned methods that are easier than this, like we could have used elimination here and solved this rather quickly. But again, the thing I want to emphasize here is we're learning the process, and we're going to do some problems, two equations and 2 variables, 3 equations and 3 variables. These are actually considered the more basic types of systems to solve. And then we're going to use the principles that we learned to use technology to solve the same kind of problems. All right, so let's move on to the next problem. All right, so first of all, this is the form we want. We want 1s on the main diagonal, 0s below the 1s, and numbers everywhere else. And so that's what we're going to try to get. So first of all, let's write this in matrix form. And we need a 1 in the upper left-hand corner. And if you notice, the second row has a leading 1. And so let's just swap the first 2 rows. So that's how we write that. So let's go ahead and do that. So all I've done is swap the first 2 rows. And let's write in the third row there. Notice the third row doesn't change at all. And so now once we get a 1 in that upper left-hand corner, we know we want to get 0s below the 1, and we're going to use that 1 to get those 0s. So notice to get that 3 to become a 0 in the second row, we'll need to multiply the first row by negative 3 and add that to the second row, and that's going to become the new row 2. So think about what you would do to get a 0 in the third row. All right, you're going to have to multiply the first row by negative 4. And when you add that to row 3, that'll become your new row 3. All right, so let's go ahead and multiply the first row by negative 3. So 1 times negative 3 is negative 3. And 3 times negative 3, or negative 3 times 3 is going to give us negative 9. And negative 3 times negative 2 will give us 6. And negative 3 times 10 is going to give us negative 30. And so when we add these, let's see, I'm going to go ahead and write the next matrix. So row 1 doesn't change. So now to get row 2, we're adding negative 3 times row 1 with row 2. So that's the green numbers there with the second row. So we're going to get negative 3 and 3 is 0. Negative 9 and negative 2 is negative 11. 6 and negative 1 gives you 5. And negative 30 and 9, that's going to be negative 21. All right. So now we're going to do the same kind of thing. And hold on just a second. I need to go back and erase my green marks. So I'm going to do that real quick. All right, let me get back to where I was. Okay, so now when we multiply the first row by negative 4, we're going to have 1 times negative 4 is negative 4. When we add that to the 4, we're going to get 0. And negative 4 times 3 is negative 12. And when we add that, so basically we're just adding these two rows here. Negative 12 and negative 1, we're going to get negative 13. Negative 4 times negative 2, here we're going to get 8. And when we add that to 5, we're going to get 13. And negative 4 times 10 is negative 40. And when we add that to 1, we're going to get negative 39. All right, so we now have the 1 in the upper left-hand corner and the zeros below. So now we're going to move down the diagonal to the next number there, the negative 11, and we want to get a 1 there. Well, I don't see any real easy way, certainly to work with row 2 and somehow get a 1 there. We could divide everything by negative 11, but we'd get fractions. But I'm looking at row 3, and you can see that 39, that's actually divisible by 13, which means we could divide all those numbers by negative 13, and that would give us a 1 in this position here. And then we could switch the second and third rows. So that's what I'm going to do. I think that'll be the easiest thing to do. So we're basically we're going to multiply by the reciprocal. Also think of that as dividing by negative 13. Let me go ahead and write the first two rows in, because those aren't going to change. So 0 divided negative 13 is 0. And negative 13 divided negative 13 is 1. 13 divided by negative 13 is negative 1. And negative 39 divided by negative 13 is 3. And so we get that last row, 0, 1, negative 1, 3. All right. So let's see. Now we can switch the rows, 2 and 3. So let's go ahead and do that. So I'm just rewriting row 1, which doesn't change. And let's switch the other two rows. All right. So now that we have the 1 in that second position in the second row, right here, let's go ahead and use that 1 to get a 0 below. So we're going to want to multiply row 2 by 11 and add that to row 3, and that's going to become the new row 3. So that negative 11, we're going to end up getting a 0 there. So let's go ahead and rewrite the first two rows. And so let's see. I'm just going to write these numbers right here. 11 times 0 is 0. And 0 plus 0, we're going to get the 0 that we want. 11 times 1 is 11. And when we add that to negative 11, we do get the 0 that we want in the second position. 11 times negative 1 is negative 11. And when we add that to the 5, we're going to get negative 6. And 11 times 3 is 33. And when we add that to negative 21, we're going to get 12. All right, we're one step away because we've got the first two columns taken care of. So now we've taken care of this part. So we're going to move down to the column, down the main diagonal to the negative 6. So notice negative 6 and 12 are both divisible by 6. In fact, to get a 1 in this position, we're going to divide by negative 6. Or again, we want to think of it as multiplication by the reciprocal. It'll be negative 1 6 times row 3 will give you the new row 3. So I'm going to go ahead and write the first two rows out, because those are not going to change. And let's divide by negative 6 here. 0 divided by negative 6 is 0. That's going to happen twice. Negative 6 divided by negative 6 is 1. And 12 divided negative 6 gives us negative 2. So you should get 1, negative 2 there. So now notice we have the form we were looking for. So now let's go ahead and write the equations. So this will be 1x plus 3y minus 2z is equal to 10. In the second row, there's going to be no x term because of that 0. So it'll be 1y minus 1z is equal to 3, or just y minus z equals 3. And the last row there stands for z equals negative 2. And so now we'll use back substitution to solve this. We can substitute for z first. So we're going to have y minus negative 2 is equal to 3, or y plus 2 equals 3. And subtract 2 on each side. We're going to get y is equal to 1. All right, so we know z, we know y. So now we ought to be able to solve for x. We're just going to basically use this equation now. So x plus 3 times 1, that's my y value, minus 2 times my z value, which is negative 2, equals 10. So again, we're just using the first equation there, but we're plugging in the y and z values that we already know. So we're going to get x plus 3 plus 4 is equal to 10, or x plus 7 is equal to 10. And let's subtract 7 on both sides, and we get x equals 3. So our final answer we write as an ordered triple, and it's going to be 3, 1, negative 2. You want to make sure you put those in the correct order. This is an ordered triple, and so the order does matter. The first value should be your x value, the second value your y value, and the last value your z value. All right, and that's the end of this video.